Welcome to a Mackenzie Institute Long Talk.
Dr. Christopher Bunt beside me is with Biotactic. He's a fish and wildlife researcher who has some interesting perspectives on fish and wildlife. Welcome.
Thank you.
Now, I was reading your paper here, good academic paper from 2011, which means the research was probably a little bit before that because it takes time to publish. But am I correct in summarizing your research in saying that we don't know enough about fish and why they behave the way they do and what sort of a fish way they like and so on? Is that about a decent summary of your research?
Yeah, that's certainly what the results of the meta-analysis that we conducted revealed.
My question is, why is that? Because we've had fishways and dams for 1,000 years or so. We've built a great number of them. And what you're basically saying is we weren't entirely sure what to build or whether it would work, but we kept building it.
Well, the conclusions of the results were primarily based on the limited number of studies that have actually been done with a variety of species and a variety of fishway designs in a variety of different locations. So certain claims that were being made about the efficacy of certain fishways were based on anecdotal information, or they just weren't based on enough scientific study and enough studies that were of fishways that were designed with a monitoring program in place as well, so that these fishway designs could be effectively evaluated and then compared. So with that study, there were even though there was a lot of data, they came from a very limited number of studies across the whole spectrum of different types of fishway designs and species that use those types of fishways.
Well, let me see if I can continue summarizing your scientific research somewhat adequately. You said words to the effect that fish may go up to a passageway, which could be a ladder or, a weir and pool thing, something that encourages fish to get up over and around a dam. So we know they went up there, but we don't know whether they went in. And if they didn't go in, we didn't know whether it was because they didn't like the structure or they didn't like the temperature of the water. Is that about right?
Yeah, well, I mean, there are many complexities when it comes to successful fish passage. The fish initially need to be guided to where the structure is located. Then they need to be able to enter the structure. And then there's certain behavioral and physiological factors that fall into play about whether or not they're going to successfully enter a structure, and then they need to be able to swim successfully from the entrance of the structure downstream from the dam to the top of the structure and the exit. So there are all different factors that go into play: water velocity, turbidity, turbulence, the types of complexity within the fishway itself that reduces water velocities or provides refugia for under certain conditions, depending on the locations within the fishway that fish might be swimming. So there's at least three different main variables that we look at when we're trying to evaluate the effectiveness of a fishway, and that's whether they're able to find the fishway itself, whether they're able to enter the fishway, and whether they're able to swim all the way to the top of it. And so we try to assign certain metrics to these different factors, and we measure certain things such as guidance efficiency, attraction efficiency, and passage efficiency, and all of those variables plus several others contribute to whether or not a fishway is going to be considered successful for passing species A, B, C, ideally the entire fish community. That's our objective typically is with fish passage research, is to make a dam as porous as possible or as transparent as possible for both upstream and downstream migrating fish.
Now, there's a great old expression that an academic would rather use another academic's toothbrush rather than his or her jargon. But in terms of the terminology you just used, fish passageway, I've spoken to European researchers who say they don't like that term because it implies the fish can pass, and maybe that is in doubt. So they use the term fishway or other terms. Do you have a good guess as to what percentage of fish can actually use these constructed structures?
Sure. Well, A good guess based on the, again, a rather limited number of studies done globally would put the typical passage range between approximately 30 and 50%.
Okay, so 30 and 50, between 30 and 50% of the fish, depending on the species. That means up to 50 to 70% of the fish either starve, die, don't spawn, get injured as they are, pushed together, or have some other fate. Is that right?
Yeah, that's right, for sure. And I mean, there have been some really interesting studies that have been done with dam removal studies. We're actually working on one at the moment in the Sturgeon River, where we've removed a dam and subsequently and inadvertently increased fish passage at the dam's upstream from where this dam was removed, as a consequence of the fish arriving at these upstream dams in better condition. They haven't spent days and days and days trying to pass the dam that was removed. They're not injuring themselves over and over and over again, trying to leap over this structure. Of course, in certain situations, as you suggested, the fish are relegated to suboptimal spawning areas downstream, or they'll resorb their gametes. They won't spawn. Or they just become so injured or so exhausted that they'll, in the case of migratory rainbow trout, for example, they might just swim back out into the lake for the year.
And so, in general conversation with me in the green room, as we say in television, before we started recording, you said that something startling to me. From watching nature documentaries, I would have thought fish love to leap up over dams, and that's just kind of what they do. But you pointed out sometimes they're leaping up and hitting their heads repeatedly on the dam and injuring themselves.
Yeah, that's exactly right. Yeah, especially with leaping species, but not all species that use fishways, or not all species that are considered to be migratory, highly migratory, are species that leap. There are highly migratory, non-leaping fish species that need to be able to be accommodated by different types of fish ladders that don't, for example, produce a series of pools that fish have to leap into, like the traditional fish ladder design. So, that sort of where there was the initial differentiation between a fish ladder and a fish way. A fish way was generally a corridor with certain types of roughness elements installed in it at specific angles, designed all to reduce the velocity in a primary flow of water that fish swim through in order to progress upstream. But some of the other more effective fishways are nature-like designs, and they mimic nature. They mimic natural structures, so they're made with rocks and boulders, and there are meanders and pools of differing sizes, and areas where there might be certain backwater areas, differences in turbulence, a lot of variation in flow that non-leaping species in particular are able to negotiate much more effectively. So, for example, with rainbow trout, they're a highly migratory, very, very strongly motivated species that typically didn't really have much of an issue with passage once they were able to locate a fishway. But in, for example, some of the stuff that's been done in Ontario with steelhead or rainbow trout migration, once they are able to locate a nature-like fishway, their passage is typically 100%. So we've gone from these sort of technical designs with early fish passage and early fish ladders to trying to mimic natural types of streams. The problem is that they take up a lot of space. They can't be built compactly, and they would take up a long. I mean, one of the largest fishways in the world is in South America, and it's 10 kilometers long. So, I mean, you've got to have an awful lot of space to be able to accommodate fish passage. It's on a very narrow slope, which is what nature-like types of fishways are typically built on.
Now, there seems to be another implication of these 50 to 70% of the fish that can't make it up a fishway, and that is their growth is stunted generation by generation. I've seen pictures of cod, maybe 3 feet long. I jigged a cod 2 feet long on my honeymoon in Newfoundland years ago. They may not exist in that size anymore. Sturgeon can be 6, 8 feet tall, taller than a human being, and weigh 1,000 pounds. Is the smaller size a result of inadequate fishways?
Well, smaller sizes of fish stocks is typically a result of overexploitation. And so when a population becomes overexploited, it's usually the larger fish that are removed from the population first. Um, there are certain characteristics related to fish size that affect their abilities to use fishways effectively. So certain fishways, for example, some technical fishways pass smaller fish better than they pass larger fish. As a result of certain things, like you can imagine, there's differential drag as a result of cross-sectional area. So a smaller fish can exploit areas, for example, along the bottom of the fishway or a fish ladder where the flows are reduced, and call it a benthic boundary layer. And smaller fish are able to exploit those areas better than larger fish within the same species, even. So there is potentially some size selection that occurs with fish passage, but in terms of size selection based on just through like filtering through a fish ladder affecting a population, I don't believe there have been very many studies that have been done on that. Mostly the work that's been done looking at why populations of fish tend to be decreasing in size as a result of, as I mentioned, overexploitation.
Now, there's a bit of a mystery, and I'm on a bit of a detective story exploration here, and it is about sturgeon. Apparently, sturgeon are almost extinct in Europe, and I guess it's a combination of the things you talk about, overfishing and no passageways and what have you. The caviar in Russia, I was shocked to find when I went there that black caviar is illegal, and I guess it's because of the diminution of the sturgeon population. Same thing in North America. I can't find anybody who knows what kind of a rapids or fishway sturgeon can get up. Do you know?
No. We know that they have a great deal of difficulty being passed through any of the fish ladders that really have been studied. There haven't been. This is the whole thing. I mean, there haven't been nature-like fishways studied in areas where sturgeon could be able to use them. So it's not to say that there aren't fishway designs that could effectively accommodate sturgeon. It comes back to the fact that there hasn't been enough work. There haven't been enough monitoring studies across different fishway designs and across the taxonomic range. But typically, sturgeon are among one of the most difficult species to pass through a fishway, as are walleye.
But now a sturgeon can pass through an open river if that's the sturgeon's natural habitat, right?
Yeah, that's correct. Absolutely,
And
they can pass up through rapids.
Given the fact that some of the many of the dams in North America are 100 years old, and nobody was there was no photography, we don't know for sure. We have folklore, I suppose. We don't really know what sort of an open river sturgeon can get up then, do we?
Well, I mean, it's based on just historical data, and based on, there are telemetry studies that have been done, tracking studies that have been done with lake sturgeon in the Great Lakes, or with white sturgeon and other species. So there's a fair bit of information available about their migratory propensity, how far they can move, under what conditions they can move. There's certainly studies that have been done to evaluate their swimming performance and their swimming abilities. But sturgeon are there. It's very, very, very difficult to predict the behavior of fish, and certainly difficult to predict the behavior of fish under artificial flow conditions.
We do know they're big and they're strong, and they can leap into the air to consume some air, perhaps for buoyancy. And there is folklore that if you hook onto one in the olden days, it could drag your canoe the length of a football field before it runs out of steam. Is that what you know?
Yeah, I mean, they used to be big and they used to be abundant. I'm standing right beside the Grand River here in Kitchener, Ontario, and there are stories that go back to the missionary days back in the 1600s, and apparently there were sturgeon in the river right here. So they were all throughout the Great Lakes, and they would have been swimming from Lake Erie up as far as they could probably get in the Grand River, which would probably be somewhere up around Elora.
All right, Christopher Bunt, and I will refer to you as Dr. Christopher Bunt. There are people who disagree with you. There are people who have published after 2011 who say, well, wait a minute, we know whether fish use a passageway. We've got RFID tags, we have remote sensing, we have all kinds of gizmos to determine this. I'm sure you've kept up on the literature. What's new?
Yeah, well, it's still, I mean, it comes back to the same conclusions as before. There still haven't been enough studies to confidently say that we can pass any species of fish over any dam of any size anywhere in the world.
Wow. Now, I could guess why. Among the reasons why bother studying fish, they were plentiful in North America until recently. The old, thing we learned in school, that the cod slowed down the ships as they approached Newfoundland, or maybe just hubris, male ego. We will build something, they will come, and that will mitigate the dam that we want to construct. To what do you attribute the lack of study?
It's been the lack of time. These studies they take a long time. The gizmos that we use are expensive to do the work effectively. What people are focusing most on when it comes to restoration of fish passage, rather than building new fishways, it's removing dams. And that really is the ultimate fish passage restoration tool. And it's gaining momentum more and more. And in terms of fish passage objectives, fish passage opportunities, I really believe that's the way to go. There are the vast majority of dams that are blocking fish movement are unnecessary. They're historic dams. The cost of removing the dam is typically much less than maintaining the dam. And it's a lot of the dams that exist worldwide, especially in North America, are just historic dams, and people are just comfortable with them in place. And again, people don't like change, but when it happens, they adapt quickly. And the fish adapt even quicker.
Wow. And you say it's a trend, and it is the right approach. I've just heard 5,000 dams have been removed in Europe, 2,000 in North America, and a couple of thousand are probably unsafe, unregulated, and just a bit upstream from a population center. And that is a huge danger for either minuscule electrical power generation or none, because the dam was closed down dozens of years ago.
Yes. All
right. What's next for you? Give me a little advertisement for your next research, your next publication.
We've got a couple of publications in the pipeline at the moment, several of which relate to fish passage. Some of them are related to some of the more interesting facets of fish homing that we're looking at, and abilities of fish to return to natal areas, the responses of fish to changes in water levels in reservoirs, and their abilities to navigate back to the same areas that they use seasonally. And again, studies looking at rainbow trout and whether or not they really do in the Great Lakes return to the same areas year and year again to spawn, because we've got data that indicates an awful lot of straying, and some of our Canadian fish tend to be enjoying a lot of time in America at the moment. So we're trying to really look at some of the wider ranging movement patterns of these fish, and whether they're using multiple rivers, multiple fishways, multiple times each year, that sort of thing. Some of the bigger picture facets, again, of fish passage research.
Well, thanks for your time. I know the first couple of times I tried to speak with you, you literally said, "I've gone fishing," which is what you do for your research. So I'm glad you haven't, but if next time I try, you have gone fishing, I will understand. Thank you.
Thank you very much for your time.
Any views expressed here are not necessarily those of the Mackenzie Institute, its speakers, sponsors, or supporters. But the Institute is dedicated to fostering public discussion, debate, and education about security matters. Google the Mackenzie Institute to join the discussion. The Mackenzie Institute is grateful to its sponsors and supporters. Some of our short pods and long talks are a result of the support of Heathbridge Capital Management Limited, the National Post, and Dundurn Publishing.